Okay, so I want to finish up on that concept there. I was loading some stuff and I had to make some space on my phone. But where we left off here in my last vid set for this was you were down here burning rock. These little X's to today, that sequence of this type of rock, you're a sawyer. You're basically cutting the rock with that torch. Again, so your constants are going to be pretty far off. So the mass gap is essentially universe sandbox. I can take an operation that is a saw program and do the whiteboard training on that to say that's inside the 5 minutes on the front end here to output those numbers on the backside, a high space where they overlap. Next, we're going to be doing trigonometry math lockdown, and you'll see two wave functions, a very tight wave and a marginal wave. So you got one with three crests in it, a high point, a high point, and a high point, and basically one with an over, and this one sets over. Well, that's Veer walking over to me on my sets. Middle part of the operation. Me, I'm every one of them. Me, every one of them. Boss, every other one of them, because then they can hit another every other one on the safety position for what that setup looks like. And that's A plus B. A plus B is going to lead to a higher result of correct answer other than just A and B up and down, because then you'll just get a pile of rock and it's not going to go nowhere, especially if you don't know the operation yet. Does it go on pallets? Does it go on bunks? You don't know any of those to lead to the result that does to the output in the timely matter. Sometimes it's put them on bunks first before you put them on pallets. You don't know that yet. Anyways, as we're going to go through here, we actually start to go through the names of the people that were on there. Obviously, Matt, Brian, James, Stephen here, Stephen and Max are going to be our guys. We have Spacetime Guy, college professor, physicist, Brian, Nobel Peace Prize physicist, probably PhDs, all of these. James at the Collider, so my version of the Hadron Collider in the Stone Mill, and what you will learn from this guy on this video. Loop and string theory, same concepts. This is the V at the top of the loop for you in the treadmill. This is the line, Bodie. And that's the string. That's the time at the top of the mountain, below the mountain. They're all still equal because they're both a box. Pressure changes that. Temperature changes that. Visual irrational, so if it's day or night, we'll change that. So they begin with James at minute 59:40. You might need this, and he's going to go through this. And some of the problems. He's frustrated, you see. Two problems. The modern models, quantum field theory, and standard model is this thing that's accurate at the weak forces, the electron position. I know the basic calculus of these things because the weight is the overset model on all that all this other stuff is doing. Saying general, got to do this on the day-night cycle. It affects, but not to the level of the macroscopic standard models that are the mass gaps, and then how those reciprocals play to the day and the phase differentials or quantum object that is. And general relativity, that generalizes these between 0 and 1 margins, the intensity of the laser, and what you could do with that laser. What you could do with that money at the end of that day. What you could do with that free will problem in general. Brownie boxes, clear right in the stocks, and you're the president at the end of the week, because that'll pose all kinds of fun entropy for this thing, won't it? No middle, as you can commonly tell, is his overall problem, or my adjustment, or my assessment, my assumption under what the general form of this statement is. You say models, you have suns, and you have stone mills, and you have standard model, or suns and general relativity, the big lensing, a moon, the I'm going to call it the accretion disk, but it's not. It's the brightness or the intensity around the moon during eclipse that shows that this light was lensed in such a way that that's physics. And to which degree or margin I'll use that science later, or how it does apply, it definitely does. That effect matters. I'm sitting here. Conversational models will lens around me if you know me. Certain things I'll do will start to ramp up the calculus on your statistic analysis of where I might be in that conversation. And so I went to this all day, every day, frustrated. Dragons. Because I feel that problem a lot of times too in the stone mills. You know, it's a people thing. It's just I'm that wolf too. I'm out there on the mountain with the rest of you. We're just trying to figure it out the best we can. I'd like to apply this model in the proper locations. Obviously, the whiteboard training for the mills, big thing into this. Let me hear your problems. I know you guys are going to have problems. It's something I've learned a lot bouncing around these places. You know, young guns or older guys that really don't have that this is the number. Let me help you show you this and help you get onto those rationals. And I'll tell you what these guys don't like about you, because I'm a psychologist as well. I'm going to get it out of them. And if I don't get it out of them, well, clearly we're perfect here and there's no reason to bitch, right? And they want more, and that's obviously still all good, because the numbers, they just keep right on going. So one of the things he said was that you can't quantify general relativity in the standard model, and what I have here is, this is basically the stone mill. There the blocks are coming in. Here it's this little arc. It's what's up, what's down. Blocks are rolling in. I need that little bit of extra trajectory, not math, not all of this. We're going to force this one up and over until it hits the down, or that spin at the top of the arc, which is going to reference to all these charms. These points on the graph about those little small boxes, and my thermal is positioned down here, the tread saw, this pallet setup, which is going to be down there at the Z boson, straight up here to the Higgs boson at top spin charm. Oh, this is the mill. It's whoever does this is gravity in that mill. Don't let anybody tell you different. There's a few bucks, and it's spread around in the secretion disk of what the entirety of this thing is. Now, I like that. Like I said, I'm posing this guy so you all out there on the internet land can say, Model A, Jordan, Model B, PhD physicist. I'm looking for something. I'm not bagging on them. Same box. When I'm done, I'm just going to N1/2 it to the mill. We're going to make that our gravity. This is our Brownie factory. Everybody, every class, forever. If it's post office, rush assault crew, it is the same Brownie factory. And that's how we're going to do this. And every term under every job that anybody could ever come to me with is going to be in that Brownie factory in one way, shape, or form or the other, and we're going to find it. We're going to make it. So as we continue down here, we start to get into some of the other ones. We got into Stefan next. And he was our physicist. Excuse me, he was... Yeah, he's our loop and string gravity here. He's having issues with quantum gravity and string theory. The assumptions of, therefore, that string quantum gravity has assumptions, like the value of a tread being burnt is 5 minutes, and you go down to the top end there on those front ends, and it's 2. That quantum gravity in this place is special relativity by that field, which is actually still the box, and you attach to this string with every other object in that mill that moves around it at causal speed, creating a physical differential in that standard. Here I have day, night, and basically I'm saying, you know, this is a tug of war. This is between Jordan and Veer. But not necessarily in the aspect of a struggle for power. Just tug. We just, whoa, too much. And I have here for the statement, 2-man flip and treads. You gotta be careful. Somebody pulls too much on one of those, somebody's gonna get bet. That's a safety standard that goes against gravity. Anybody who do gravity in here, reference that Higgs boson, pull off that Z boson. I ain't. But I'll be damned if I didn't step up in here. Here's a W boson in this aspect that's like, well, saw coefficient, real graph numbers and papers that come out of that. Obviously, that is the answer. But is it the one where you did it at the spot? And will it be that one next time when the embodiment of all these forces correlates to the air acoustic flutter or baryonic harmonics? So you either got the devil or God on the table in front of you. So next we have Max. He's our physicist. He's our, he calls his problem physicist, what is this? Not eagerness. Ignorance. Here we go. And that's a vet and a doctor. They're basically the same thing. But a doctor, for more people reasons, it really depends on the triple point. Nowadays, don't it? And that's to say a physicist and a biologist. They're so much different from each other. This is a true problem. I quantify this with the marshmallow, XYZ, and general relativity. If you've never done it like that, it would be hard to correlate your nutrient solution and anything more beyond that in chemistry and how the effect crashes in solution when you have no parts for any increments of what one is and you just try the whole bottle for your first run. It's the right answer in the fact that it's wrong, negative calc, but you don't know why. And we'll get into that later with a seed. This one's hard and this one's soft. It's essentially acidic ground and that plant capitalizing on it, or one that's very hard that has poor conditions genetically to the amino acid changes they're created, which is obviously the standard model, these connections, but it ain't. This is to say that this is an action at a spooky distance, that calculus can't quantify the differential of this Epstein sphere 2-mass black hole. Most time it'd be a neutron star in all of those families, or something that's rational and common sense in those ideas, and often it's not that way. And I continue on here to say, what is the difference between the mass gap and the Mills mass gap? This Bluestone Mill, why can't that be a unified field theory in the way that I'm applying these mathematical constants in that form? Here I'm just applying scales and thermal and rock n1/2 to a calculus standard. This one, then this one, and then this one still creates one in an average of a 5-minute burn. Every time that standard goes down, that concept is Euler's number and a time paradox of which line leads to the best result. Which line? This is an aspect of topo and triple point